Hello and welcome to a Reigate Maths video focusing on the Trapezium Rule section of the Numerical Methods topic for the second year of the Edexcel A-Level Maths. My name's Simon, and in this video we're going to look at the basics of where the Trapezium Rule comes from, as well as looking at some examples of how to use it. The main purpose of the Trapezium Rule is that it approximates areas under curves. Now we know from what we've done in the past that if we have a curve and an area like this between A and B, we find that area by integrating. So here the area would be the integral of f of x between A and B. Sometimes though, we can't necessarily integrate. In that case, what we do is we look to use the Trapezium Rule to find an approximation. So the Trapezium Rule works by taking the area that we're trying to find and breaking it up into trapeziums. Now we could do this very simply, breaking it up into, say, 2 trapeziums, like this. But that doesn't give you a particularly good area, or a particularly good approximation. So we can break it up into even more. Let's say, for the sake of argument here, 4 trapeziums. We can see already that we get a much better approximation. Now the key thing with these is each of these is going to need to be the same width, because otherwise we can't come up with a nice sensible formula. Now for the purposes of the standard kind of integral notation, our first x value is a. We're going to call that x0. And we're going to increase the x values thusly until we get to b, like that. Now we know the area of a trapezium is half the sum of the parallel sides, which we're going to deal with in a minute, times by the distance between them. In this case, the distance between them is h. But what about the parallel sides? Well, if we think about this as a y-coordinate, well, this is f of x0. This one is f of x1. So this area is going to be a half f of x0, which we're going to call y0, plus y1 times by h. And we can continue in a similar way. This one is going to be half y1 plus y2 times h. This one, a half y2 plus y3 times h. And then the final one, a half y3 plus y4 times h. Now we can see, if we're going to work out an approximation for this area, we take all of these and we add them together. And we can tidy this up and factorize a little bit. You can see that each of these terms has a half in and an h. So we can take a half h outside our bracket, leaving us with the following. We can also simplify this bracket here. We can see that all of these middle y values, which are known as ordinates, double up. The first one, y0, which remember is a, and the last one, y4, which is b, are singles. And then we've got 2 of the rest. This is the formula for the Trapezium Rule for 4 trapeziums. If we have more trapeziums, then this formula will be extended. And in general, the formula is given to you in the formula book. this is broadly how it is given to you in the formula book. Now we've got a few bits that we need to annotate here. The first one is n. N is the number of trapeziums. Usually though, this part of the formula for this new specification you don't actually need to worry about, because h, the part that's in the formula, is going to be xn minus xn minus 1. So it's the difference between two consecutive x values. Now, this formula can sometimes be confusing, and you can think of it in this way. The h over 2, as we've seen, that's just this. The y0 is the first y value. Yn is the last y value. And these, well, that's just the rest of them. So let's have a look at this formula in practice. Here's the example. Given that integral there, use the trapezium rule with the values of y at x for these given values to find an approximate value for I, giving our answer to 4 significant figures. Now, the 4 significant figures part means that we want to be working to at least 4 significant figures, probably 5, so that we don't round too early. Now, with this particular example, we can work exact, which is nice, but others might not be quite so easy to do. General advice is, if you can give your answers exact, then you should. Now, sometimes in the exam for this, you will be given a table. If you're not, just do a table for yourself. So we've got the x values, 1.5, 2, 2.5, 3, and 3.5. We can see here already, without calculating anything else, our h. Because don't forget, our h is what we do to get from each x value to our subsequent next x value. This is our value of h. So to find all the values of y, we take these values of x and put them into this equation here. So 5 times 1.5 minus 7 over 1.5 minus 1. Take some time to do that now. So these are the y values you should get. Now, all we need to do is use the formula. So the integral that we're trying to find, I, is approximately a half times h, which we've seen is a half, times the first y value plus the last y value plus 2 times the sum of the rest. From here, you can just put the whole thing in your calculator, but personally, I prefer to take an extra step just to do a little bit more working. Effectively, I just calculate this, what's inside the bracket first, and then work it all out after that. So 1 plus 21 over 5, we get 26 over 5. This bit, 2 times 3 plus 11 over 3 plus 4, we get 64 over 3. And then from there, I just stick it in my calculator. Now we do need to be careful. The question says give our answer to 4 significant figures. If we use our calculator will probably give this out as an exact value, as a fraction. If the question says to a certain degree of accuracy, you should not give it as a fraction, you should give it to that degree of accuracy. So here, 4 significant figures. And that's it. That's the trapezium rule. Now you can have a few additional bits on top of doing this example. For instance, you might get the question asking you to how to improve the approximation. And the answer there is use more strips. If we make thinner strips and use more of them, we will get a better approximation. You might get questions like this. So we've got 1.5 to 3.5, 5x minus 7 over x minus 1 plus 3. So we need to know that this is the thing we just found plus the integral of 3. We work this out and add it to what we got, that kind of thing. If you've been given a graph, you might also be asked whether this is an under approximation or an over approximation. Now, because you can work this out in your calculator, you can actually see very quickly what it comes out as. The reasoning is a little bit difficult, or a little bit precise. So if this value, which in this case it is less than the actual value, then it means it's an under approximation. And the reason is the tops of the trapeziums are mostly below the curve. If it's greater than the actual, it's an over approximation. And in that case, the tops of trapeziums are above the curve. You may also be asked to actually work out the exact value of the integral and then work out a percentage error. But broadly, that's the trapezium rule. That's where it comes from, where the formula is, and then an example. Thanks for watching.